Hello there, everyone. This is Jesse Gallarzo bringing you another installment of the Python Learning Workshop. Um, so last time when we were here, we went ahead and talked about a couple topics. We went and talked about the different data types that one can put into a variable. Then we went ahead and talked about if statements. Now, before we go ahead and jump in to the two topics that I want to go ahead and talk about today, I want to go ahead and go into our tic-tac-toe file and go ahead and make some changes real quick. Now, on the last video, we had a quick recap as far as the different data types that one can put on variables, and that's what we're going to go ahead and do right now with our tic-tac-toe file right here. So as you can see, there's a series of variables right here that have been commented over. For right now, we're going to go ahead and leave game grid alone, but we're going to go ahead and uncomment game over and answers. Okay. Now, what exactly are we going to define these variables? For game over, what we're going to do is we're going to make this into a Boolean variable, or it's going to have the Boolean data type within this variable. And we're going to go ahead and define it right here. Game over is equal to false. And then for answer is going to be str, or string, with parentheses. Really quick, what we're doing right here, the variable game over is going to have a false variable to it, or the variable is going to be a false. What we're going to do with this later is we're going to use this variable to determine when the game should stop. And down here for answer, what we saw in the beginning of the last video was when we created empty variables that already have a data type declared. For answers, we declared it as the string data type. So whatever we put our answers, or whatever answers get put on here, they're going to come out as strings, which is what we're going to end up using for the answers that get placed onto our tic-tac-toe grid. Now, so we're going to go ahead and leave that alone for now. And so now we're going to go ahead and get into the topics that I wanted to get into today, which were lists and loops. As far as lists and loops are concerned, I feel that they're probably one of the two main topics that we're going to be focusing on for this workshop. But they're actually going to be the two main topics that are going to pull to this program together and run what is supposed to run, which is the tic-tac-toe game. So first, let's go ahead and talk about lists. Let's go ahead and go into our console right here. Now, a list is a data structure that essentially holds multiple types of variables or data types values. So, for example, if we were to write A is equal to 17, print A is equal to 18, print A is equal to 19, print A. So we can kind of see that we keep changing the data on variable A. We keep changing it to 17, then to 18, and then to 19. But what if I didn't want those variables changed? What if I just wanted them all stored within the one variable? You can do that with a regular integer variable, so we're going to go ahead and create a list to do that for us. So now we're going to go ahead and define our variable, A list is equal to, and this is important whenever you're defining a list of data types, we're going to go ahead and do the open bracket, and then we're going to do the same number, 17, 18, 19, and press enter. Now we're going to print a list, and see we get the same thing. In between the brackets, we get the 17, 18, and 19. And there's a little bit more functionality aside from just creating the list itself. You can go ahead and print individual values from that list. So if I were to type in A list 1, I get 18. So what's going on right here? The first value that we got is 17, but when I asked for the first value or value 1 on a list, we're getting 18. So the reason that we're getting that value is because whenever we call the index to a particular structure, we don't start at the 1, we start at the 0. So let's go ahead and try that out. A list 0, and we get 17. And so if we're to type in 2, a list 2, we get the last value, that's 19. What happens if we try to access a value that isn't defined within our list? So we can try a list at 3, and you can see we get an index error saying that list index is out of range. So it doesn't count them as 1, 2, 3, it counts them as 0, 1, 2. And whenever you try and access something outside of the parameters of the index, you'll see right here, you'll get a list index out of range. So another neat thing that you can do with lists, so we're going to do a list is equal, I'm sorry about the a list at 0 is equal to 99. Now we print a list again. And we can see that the value for at 0 for a list has been changed from a 17 to 99. And you can pretty much access and change variables within the list so long as you know the address or the index for the value that you want to change. And there's many more commands that you can run off of list data structures. You can append things to the end of a list. You can go ahead and delete and do all kinds of neat things with lists. But as far as our workshop is concerned, all we're going to go ahead and do is create an empty list variable, and we're going to go ahead and access them individually the way that we have right here. Now, before we go ahead and create our list and the tic-tac-toe file, there's one more topic that I want to go ahead and go over, and that topic is known as loops. Now, loops are a very important part of any type of programming language because they allow us to execute the same piece of code for X amount of times. What that means is over here we have this file with the if statements. Let's say that we needed to do this check about 5 or 6 more times. So instead of just checking once and then finishing, you would take all of these if statements, put them underneath a for loop, which is one of the types of loops that we're going to be working on, and just define that loop to run 5 times. And so this piece of code is going to come out 5 times. So we don't have to keep repeating it over and over and over, because otherwise we'd have to copy this bit of code 5 different times to go ahead and do that. And obviously that's going to take up too much space in our program, and it's going to be too confusing to read. So let me go ahead and give you guys an example of how that loop works. So for I in range of 5, colon. So we can kind of see it looks very similar to the way that the if statement is structured. So we have right here the keyword for that indicates that this is going to be a for loop statement. Right here, I is a variable that was created within the scope of the loop, or I only exists inside of the loop, and you'll see how that applies to us in a minute. So, and then in range right here, what in range means is that this loop is going to run in the range of 0 to 5. So backing up real quick, when we were talking about indexes and things starting at 0, it also works the same right here with for loops. So when we're saying in range of 5, what we're really saying, we're going to do this from 0 all the way to 4, which altogether means we're doing this 5 times. Let me give you a better example of what that means. Okay, so we're going to type in the for loop, and you can see that we've already have an indentation right here. So we're going to go ahead and put print I. So it's going to print the numerical value of I, which when it's first created is going to be at 0. Now, for the if statements that are right here, we're going to go ahead and in respect to the indents that we have already set up here, we're going to do that as well. So we're going to indent this if statement. The print was already indented, so we're going to do that again so it could fall under the if statement. Same thing right here with elif, else, and then print. Sorry. Oh, hold on about that. Let me just go ahead and see what's going on right here real quick. Do that. There we go. But they're still not balanced out right. I'm gonna go ahead and delete this one more time. One more time. Like that. And okay. then like this. So again, you just want to make sure that you respect the indentation happening all the way from the for statement, the for loop statement right here. There's an indent. It's going to print out the variable I, and it's going to go through this right here 5 different times through this conditional statement. So let's go ahead and run that right now and see what that looks like. Okay, print I. Oh, okay, that's where I was messing up. Make sure when you do your print statements, you encapsulate them in the parentheses. Let's go ahead and run it now. So it's going to ask us again how old we are. I'm going to go ahead and put 27. So it's going to go ahead and print out the number, which, like I said, is going to print out I, which starts at 0, and then go all the way to 4. So it never actually touches 5, but it's still in the range of 5, from 0 to 4. Print out all those numbers. Since it only asked us for the input of our age once, it's going to take that variable and compare it 5 different times, which means I ended up right here. I ended up right here telling me 5 times I need to go get a job. And then at the very end, the variables that are outside of the for loop that were only printed out once. So, as you can see here, the for loop allows us to execute all of this without having to write it so many times. And that's one of the benefits of writing the for loops. And we're actually going to use several for loops within the context of our script. But before we go ahead and do that, I just want to go ahead and point out that you can go ahead and do what is known as a multiple for loop statement. So what we can go ahead and do, I'm not going to go ahead and run it, but just to give you an example, and you'll see that right now in a minute, for j in range of 3. So now what would happen is, ignoring for the time being the indentation, that all of this right here, instead of running 5 times, I was originally right here, it's going to run 3 times, because for every one iteration of this loop right here, it's going to run this piece of code 3 times. So we'd get a total of 15 statements if we were to run this. We're not going to do that right now, but just giving you an example. And the reason that I'm explaining that is because now I believe we are ready to go ahead and create our game grid. So our game grid is going to look a little bit weird when we're first writing it. I just need you to go ahead and bear with me right now. So we're going to do open brackets again. So there should be a total of 2 brackets, 1 bracket inside of the other one. Inside of in the inner bracket, we're going to go ahead and do apostrophe space apostrophe. So we're essentially encapsulating this space, empty space, within the 2 apostrophes for I in range of 3. So what does this mean? Inside of this inner list, we're going to go ahead and add 3 empty spaces to that list. So it would essentially have the length of 3. It would have 3, they'd be empty, technically not empty because they have the spaces in them, but right now, for argument's sake, we're going to say it has 3 empty objects inside of the list. Okay? And then so now we're going to go ahead and move past the inner list into the outer list. Go ahead and write space for j in range of 3. Okay, so it looks like we just pretty much repeated the same thing, and the syntax was repeated, but we're not doing the same thing. So we already dictated and said that in the inner list, we're creating a list that has 3 empty variables, or 3 space variables inside, or 3 space variables inside of the list. And now we're going to do this 3 more times. So we're going to create 3 lists, and inside those 3 lists, we're going to create 3 empty lists, making our 3-dimensional list, which is what I want to go ahead and show you in my notes right here. If anyone on here is familiar with how matrices work, it's pretty much a similar principle. We're making a 3x3 matrix right here, 3 rows, 3 columns. Now the 0 through 2 going right here and the 0 through 2 going down here are going to be the way that we're going to access these individual values. So for example, if we wanted to access the value number 1, we would go ahead and ask for the index of game grid 0, 0 to give us this one value. Now let's say we wanted the value of number 5, we'd go down 1, 1, and that's how we would get the value inside of 5. So let's go ahead right here. Let's see. What are we going to do? Now that we have a concept of what's going on as far as loops and lists are concerned, we're going to go ahead and start writing that code into our script right here. So we already went ahead and create our 3x3 game grid. This is what our 3x3 grid is going to look like. And eventually we're going to go ahead and see these different values get populated with X's and O's so we can go ahead and play our game. So now we created our grid. Let's go ahead and go right here, def place move. Let's go ahead and erase this right here while still keeping the indentation. So now a lot of things are going to happen right now. Just go ahead and bear with me, write down all the different variables that are being written over here, and then at the end of this I'm going to go ahead and explain exactly what it is that I did. So I have global answer, then global game over. Now these variables, they've already been created right here. So why are we defining them again within the functions? The reason being is because without going into too much of an explanation right now, we're going to talk about this more at the end when we talk about functions. These variables that have been created inside of functions can't exist or don't exist outside of the game. Outside of the script. Now, game over and answer do technically exist outside of these functions and can be accessed by these functions, but in order to change these values, we need to go ahead and put the global keyword inside of the function. And again, this is going to make more sense when we talk about functions and more specifically the scope of functions. But all you need to know is that we're going to manipulate these values inside of place move. So we need to put the global keyword in front of them. Okay, so let's go ahead and continue. So we're creating a variable, ans is equal to input apostrophes, and inside we're going to ask X's or O's. So we're going to be prompting the user to tell us what is he going to put down. Is he going to put down X or going to put down an O? Create another variable, index, equal to int, input. So we're going to be asking for an integer value here. Apostrophes. What position? So then we're going to ask the user after we get what value he wants to put into his grid and what position he wants to put that value into, which is going to be these right here. These numbers are going to be technically going to be your index. Okay, let's go ahead and continue. Count is equal to 1. This count variable is going to be important right now for our loops, and you'll see right now in a minute. So here's going to be the first for loop that we're going to create. For I in range of 3. Okay, colon. So it's our first for loop. Second for loop, for j in range of 3. Colon. So similarly to how I explained how this worked, I said that this was going to go for 15 times. This, since we defined it 3 at this first range and then 3 at the second range, is going to run a total of 9 times. Or at most, it's going to run 9 times because we don't want to keep checking for moves after we placed it into its position. So we're going to see that right now. So here's our first if statement. If count, which we defined already as 1, is equals to index, colon, which index is going to be the numerical value. Oh, I'm going to fix that. The numerical value that we asked for what position is going to put into. If those numbers match, then you're going to go ahead and go put game on the game grid at position I, J is going to equal to the variable ans, which was the answer that we're going to prompt from the user. The global variable answer is going to equal to ans, and we're going to use this variable answer later, as you will see. Then return. Return is going to be another one of those keywords that we're going to go into more depth once we talk about what functions are. But just know that once we hit this line, this is going to return back to where control to where the function was originally called, which is it's going to eventually be right here. But just know once we hit return, it's going to end all of this right here. And only if we hit the condition for the if statement where count is equal to index. So for example, let's say that the index would be 1, right? So it'd be the first one here. So if count, which is already 1, is equal to index, which is what we were asked for the user to put, the user wants to put the value at 1, that means the game grid, originally I and j would start at 0. So it'd be game grid 0, 0, 0, 0, it'd be right here, is going to equal to the answer or the input that we got from their user originally. So let's say if I were to put x would go under that this first value right here. It would store the answer for later use, and then we would return. So let's say that 1 is not going to be where we're going to store our x or o. We're going to do it at 4 or 5. What happens then? How do I keep going? So now we're going to do the else statement. If it doesn't meet the criteria of count equaling the index, else. So we're going to put count is equal to count plus 1. So all this is going to do is just increment it. So if it doesn't match, if count does not match index, we're going to increment the amount of count until we do hit it. And then we get where we need to be as far as the grid's concerned. So let's say again, with the example I said right now, I want to go to 4 or 5. It's going to keep going because count doesn't originally equal 4 or 5. It's going to equal 1. So it's going to keep incrementing, keep incrementing, keep incrementing. And then these values are going to keep changing. So it's going to go from 0, 0 to 0, 1 to 0, 2. It's going to stop because it didn't find the right answer in that row. So it's going to go next. Game grid 1, 0, 1, 2, which is where 5 is going to be at originally. So we go to 1. I'm sorry, we go to 1, 1. That's what I meant. To get to here. And then this value is going to go ahead and change to whatever the answer was given by the user. Okay, so let's go ahead and see what that looks like in here. So outside of print grid, we're going to go ahead and type, let's see, place move. Now let's go ahead and run our code. Okay, let's go ahead and go to the console, run it. So here's our rules. Here's our grid. And so here's the input now that we're being prompted from the program, X's or O's. I'm going to go ahead and put on X. It's going to ask me for what position. I'm going to go ahead and put 1. What happened? Well, we went ahead and added X onto the position 0, 0, or I guess you could say the index 1 into our grid. But because we haven't defined what that grid is going to look like, we are not really looking at it right now. We only created this temporary grid where it just prints out what the grid should look like, but not what the actual grid is. So that's what we're going to go ahead and update next. Now we're going to go ahead and change print grid to show the actual values that are within our game grid, which is right up here. So this is how we're going to go ahead and do that. In the first lesson, I went ahead and talked about adding variables or adding strings together. So it's going to look a little bit similar to what we were doing, but just go ahead and bear with me. So we're going to go ahead, erase the 1, and put an apostrophe on there, plus game grid at 0, 0, plus apostrophe. So we're going to go ahead and do the same thing right here. We're going to copy this from the plus all the way to the apostrophe. We're going to copy it, and then we're going to place it right here. Apostrophe, then paste that. let's see what we got right here real quick before I make any more changes. Apostrophe vertical bar. Apologize if this is a little bit confusing. I'll go ahead and show you how it's all supposed to look like when we're done right here. Okay, plus. There you go. So let's go ahead and take a look at exactly what it is that I wrote. So this is going to look a little obviously different from what we wrote down here. So what we're going to do is we're going to replace the numerical values with the calling right here from the game grid. So it's going to get the value 0, 0 in the game grid. The value of game grid at 0, 1. Sorry, I need to go ahead and update that. We're going to change that to 0, 1. And then we're going to update this one too to give us the value at 0, 2. I'm going to go ahead and stretch this out so you can kind of see it a little bit better. So this is what we went ahead and did. So now in between where the numerical values were originally at, we went ahead and replaced it with the values that are going to be at game grid 0, 0, 0, 1, and 0, 2 respectively. So that's going to give us our first rows right here, which right now, the way that we define that list right here was just with an empty space. So let's go ahead and run that again. And you can see right here that instead of the numbers now we got is white spaces. So we're going to go ahead and do the same thing. We're going to go ahead and replace all the other print statements right here, but then we're going to fill it in with all the other variables from the 3D list. So let's go ahead and just copy that. We're going to update those in a minute. So now we're going to change the column. So it's going to be column 1 that we're going to be checking. Or row 1, I'm sorry. And then the very bottom is going to be row 2. So that would pretty much have it set up the same we have right here. Row 1, 0, row 1, and row 2. Let's go ahead and run that. So, okay, I'm going to go ahead and stretch this back so we can see this a little bit better. Okay, so I don't know what's going on right here. Let's see if we can run that again. Here we go. So now we have an empty grid. We're being prompted for X's or O's. So I'm going to put X. I'm going to put position 5. What's going on? We're still not seeing anything. Now, the reason that we're not seeing anything is because there's nothing else that's happening right here. We're only printing out what the grid looks like before anything happens to it. We're making moves, but we're not seeing them be applied to our 3D list right here. Now, it looks like I already went ahead over the time that I wanted to. I feel like I've gone over a lot of topics enough as it is. So go ahead and digest what it is that I've talked about as far as lists are concerned, as far as loops are concerned. On the next video, I'm going to go ahead and finish up on the topics of lists and loops. So if you have any kind of indiscrepancies as far as what you don't understand, you know what? Go ahead and look up any errors that you might have run into. Or what we can do, we're going to go back to downloads. We're going to go to our folder. I went ahead and completed the tic-tac-toe file already. So I'm not going to open it with Anaconda. I'm going to go ahead and open it with, let's see, I'm going to try and do a Sublime Text. We're going to open this up with Sublime Text. And so the code that we're going to ultimately get to has already been written. And the reason that I'm showing you guys this is so that you can kind of see and reference what you guys are doing wrong. So maybe you might not be typing something correctly, or maybe I went too fast when I was showing you how to go about writing the game grid onto your grid itself. So you can always use this as reference to see that you're doing something correctly. And so like I said, I'm going to go ahead and leave it here for now. We're going to go ahead and jump on this topic for the next video and then wrap it up with functions for our last video. Thank you.